Alright, let's try this again. Completing the square.
2.
So this is a different strategy that you can use when you can't factor using the area model. So I'm going to actually show you how to use this with something that you could factor just so that you believe that it works to begin with. Okay? So let's take this situation, x squared plus 7x plus 10. We already know, because it was the first problem we did, we already know that this is what it factors to. But we're going to use completing the square to come to the same answer so that you can see that it actually works. So how this works is we know that we're looking for x-intercepts so that we know that y wants to be 0. So we're going to rewrite this x squared plus 7x plus 10 equals 0. Okay? We're going to change this third term. We're going to create a different third term that's going to create a perfect square. And I'm going to explain that in a second. So first we're going to just do some algebra. We're going to go minus 10. This is legal. X squared plus 7x plus some number that we're going to create equals negative 10. That's where we are. Okay? Now, what we want is we want to be able to create something where like my terms are like x plus 3 times x plus 3. So I want to get the same number multiplied by itself in this factored form, because I would write that x plus 3 squared. It's important that we get that type of square. So we're going to create what works here. So if I look on here and take what I know so far, I know that this box has to be x squared, and I know that this box right here, this and this, need to equal 7. But I also know I want them to be the same, so I need the same number plus itself equals 7. In other words, I need 7 divided by 2, or 3.5 plus 3.5. So 3.5x plus 3.5x equals 7x. Hopefully that makes sense, okay? Because I want to make sure that I can factor it to the same thing twice. Now I gotta find this spot. Well, I know this is 1x, this is 1x. This only can be 3.5. This only can be 3.5. So this has to be 3.5 times 3.5, which equals 12.25. So I need for this term right here to be 12.25. Okay? Now I have a perfect square. But here's the thing, I can't just write down 12.25 right here and not write down 12.25 on the other side. So I'm going to write 12.25. Can I borrow? There it is. Okay? So now I'm going to erase this, but you can hopefully see where it came from, and please don't erase it on yours. So what I know now, what you just saw, is my factors are x plus 3.5 times x plus 3.5, 3.5, should equal 12.25 minus 10, which is 2.25. Okay? Yep. Now, the key about this is I can rewrite this in a way like so. So I get x plus 3.5 squared, because I have x plus 3.5 times itself, equals 2.25. And again, this is a lot of algebraing right here, right? So I get that right here. Now, how do I get rid of the square? I take the square root, and I'm left with x plus 3.5. If I take a square root on one side, I take a square root on the other side, so I get both positive and negative, and the square root of 2.25 happens to be 1.5. Okay, you can check all this in your calculators and whatnot, but that's what it is. And now I solve it. So I have x plus 3.5 equals positive 1.5 or negative 1.5. So I create two little problems. I might say, okay, well, x plus 3.5 equals positive 1.5, and I'm going to solve that. Can they see me without you touching it? Simple question. Can they see it? Nope. Okay. X plus 3.5 equals 1.5.
Kinda.
Can they see this?
Yeah, they can see that.
All right, perfect.
Not the other one.
Perfect. Minus 3.5 minus 3.5. X equals 1.5 minus 3.5 is negative 2. Is that right? Yep. Negative 2, 0. Oh, those are wrong. I need to change those. And then on this one, x plus 3.5 equals negative 1.5. We have minus 3.5, minus 3.5, x equals negative 5. I made a huge mistake. This one isn't 3 and 7. This is supposed to be x minus 2 and x minus 5. That's what it was before. So you're probably looking at this like, that doesn't match what we did earlier. That's why. But you can see there's your minus 2. And there should be minus 2 and minus 5. Sorry, plus 2 and plus 5. There's your plus 2 and plus 5 because if we found the roots, it'd be minus 2 and minus 5. Okay? So my x-intercepts here would be negative 2, 0, and negative 5, 0. My x-intercepts, if I found them from this one, would have been, x-intercepts would have been negative 2, 0, and negative 5, 0. So we did the same thing. All right, so we're going to do another example of this, except now we're going to take something that we actually can't factor. Let's say if I had this quadratic equation and I try to factor it, I don't ultimately need to get two numbers here that multiply to 11 and add to 8. Those two numbers don't really exist as far as like basic numbers that you would know in your head, so you cannot factor this. So my next step that I would move to is completing the square. So I'm going to do that same process. I'm going to take this, it's already set equal to 0, so I'm going to say minus 11 and minus 11. So I have x squared minus 8x plus some number which I don't know equals negative 11. I'm going to create that perfect square from this. So again, if you don't quite remember, right, I have x squared here. I want these two numbers to be the exact same number. And when I add them together, I get negative 8. So basically, I'm just taking negative 8 and dividing it by 2. So this is negative 4x, right? Which means that this is going to be negative 4 times negative 4, which is going to be 16, right? Because this is x, this is minus 4, this is minus 4. Negative 4 times negative 4 is 16. So this right here becomes a 16. And again, I can't just write 16 here without putting a 16 over here. I gotta keep my algebra right, I have to keep balanced. So again, we just found out that my two factors are x minus 4 times x minus 4. So it's really x minus 4 squared equals what? Negative 11 plus 16 is 5. Right? Yep, I'm on the right track. And now I'm solving this thing algebraically. To get rid of a square, I take the square root, so I have to do it on both sides. This leaves me with x minus 4, and this leaves me with positive or negative square root of 5. 5 doesn't have a perfect square root, so you can just leave it as a square root of 5. And then I kind of split this into two problems. So one problem says x minus 4 equals the square root of 5, and the other problem says x minus 4 equals the negative square root of 5. Because remember, it can be positive or negative. So, plus 4, plus 4. X equals 4 plus the square root of 5 here. Plus 4, plus 4. X equals 4 minus the square root of 5 here. So my roots, my two x-intercepts are my x value is 4 plus the square root of 5, 0. And my other one is 4 minus the square root of 5, 0. Those are my two roots. And the square root of 5, I can kind of get a calculation for approximately what that is. But these are the exact x-intercepts. Because when y equals 0, x is either 4 minus the square root of 5, or x was 4 plus the square root of 5. We'll be doing a lot more of this in class. Let me pause you right here. Alright, so it's the last piece. These are your steps to completing the square. So first you're going to free that third term with algebra. That's when we use the added or subtract it to move it to the other side. You're gonna look at that middle term and you're gonna divide it in half because remember you want the same number to add up to the middle term. And then you're gonna square it to get your new third term, okay? You're gonna take this value and put it on both sides of the equations, right? So if you had like that negative 7x, it was 3.5 and 3.5. You squared it, which was like 12.5, I think. And you put 12.5 on both sides, okay? Then you rewrite the equation. Now you have the two factors for this new perfect square. So that's when you rewrite it like, x minus 6 squared. You rewrite it as a perfect square on the left-hand side. And then finally you solve it algebraically. Don't forget to do the plus or minus when you take the square roots. This is the whole thing. It's kind of down. I shortened it, obviously, but hopefully you guys got it. We'll be doing this in class. Alright, shout out. I need to give a shout out to Dagon and give a shout out to my class. Oh, somebody who came in and got some extra work. Shout out to Simone, missed a couple days, came in, got her done, now you're ready to go. You should be all good with that retake, so thank you for taking care of that. Alright, Miriam, do you have anything to say?
Oh yeah, I just saw a spider like right over there.
She did scream a little bit. She did startle me, but I stayed cool. You would never know. Alright, deuces.